Hello and welcome to G Fun Facts Online. Today, we're taking a short trip, cosmically speaking. Just 18.2 light-years from Earth, in the constellation Gemini, lies a faint, reddish star that has become a hotbed of astronomical intrigue. This is the story of Gliese 251, its planetary system, and a persistent hunt that revealed a new world right in our cosmic backyard. At the heart of this story is a planet named Gliese 251b, a so-called super-Earth that is challenging our ideas about where life could exist in the galaxy. Before we get to the planet, let's meet its parent star. Gliese 251 is a red dwarf, the most common type of star in the Milky Way. They make up about 75% of the entire stellar population. Imagine looking up at the night sky. For every star you can see, there are at least 3 invisible red dwarfs lurking in the darkness. Our star, the Sun, is actually something of a rarity. Gliese 251 is much smaller and cooler than our Sun, possessing only about 36% of its mass and radius. Its surface temperature is a relatively chilly 3,342 Kelvin, giving it that characteristic reddish glow. Their sheer number makes red dwarfs prime targets in the search for exoplanets. Statistically, they should host a colossal number of worlds. Plus, their small size makes it easier for astronomers to spot them. We find planets around them using something called the radial velocity method, which essentially looks for a tiny wobble in the star's position. This wobble is caused by the gravitational tug of an orbiting planet. As the star wobbles towards and away from us, its light gets slightly blue-shifted and then red-shifted. By measuring these shifts, we can detect a planet and even estimate its minimum mass. But red dwarfs are also tricky. Because they are so dim, a planet has to orbit much closer to them to stay warm enough for liquid water. This close-in region is called the habitable zone. This proximity can lead to a phenomenon called tidal locking, where the planet constantly shows the same face to its star. You'd have one side in perpetual, scorching daylight, and the other in a permanent, deep freeze. Another major problem is stellar flares. Young red dwarfs are famous for their violent tempers, blasting out bursts of high-energy radiation that could strip the atmosphere clean off any nearby planet. However, there's a huge upside. Red dwarfs have incredibly long lifespans. We're talking trillions of years, far longer than our Sun's expected 10 billion-year life. This provides a vast, stable timescale for life to potentially emerge and evolve. Gliese 251 is about 6.8 billion years old, a bit older than our Sun, so it's likely settled down from its wild youth, making its system a more stable place. The journey to actually finding a planet around Gliese 251 was a perfect example of scientific persistence. It was a roller coaster of discovery, disappointment, and eventual triumph. In 2019, initial observations hinted at not 1 but 2 planets. The data suggested a world with a quick 1.7-day orbit, and another much farther out, taking 607 days to circle the star. This was exciting news, but the celebration was cut short. A follow-up study in 2020, using a much more precise instrument, completely refuted the discovery. It turned out the signals that looked like planets were actually just the star itself being noisy. Red dwarfs have magnetic activity, like star spots, which are similar to our sunspots but can be much larger and more dramatic. This activity can create signals in the data that perfectly mimic the gravitational tug of a planet. This is where the hero of our story comes in, an instrument called CARMENES. CARMENES is a high-tech spectrograph in Spain, designed specifically to find Earth-like planets around red dwarfs. Its genius lies in its dual-channel approach. It observes the star in both visible and near-infrared light simultaneously. This allows astronomers to distinguish the star's own activity, or red noise, from the true subtle wobble caused by a planet. The CARMENES data confirmed that the first two signals were indeed just the star's rotation and magnetic cycles. It was a false alarm. But the science team didn't give up. Digging deeper into the wealth of data from CARMENES, they found another, much more subtle signal they had previously missed. After carefully ruling out every other possibility, they confirmed it. In 2020, they announced the discovery of a single planet, Gliese 251b. So what is this world actually like? Gliese 251b is classified as a super-Earth. This term simply means its mass is greater than Earth's, but less than that of our ice giants, Neptune and Uranus. We don't have any planets like this in our own solar system. Gliese 251b has a minimum mass of about 4 times that of Earth. It orbits its star very closely, at a distance of just 0.08 astronomical units. For comparison, Mercury orbits our Sun at about 0.38 astronomical units. This close orbit means its year is incredibly short. A full trip around its star takes just over 14 Earth days. Because it's so close to its star, the planet gets blasted with radiation. Its estimated equilibrium temperature, which is the temperature it would have without an atmosphere, is around 351 Kelvin. That's about 78 degrees Celsius, or 172 degrees Fahrenheit. That's likely too hot for liquid water to exist on the surface, placing it just inside the inner edge of the star's habitable zone. Of course, a thick atmosphere could change this calculation dramatically, but on the face of it, Gliese 251b is probably a scorching, inhospitable world. But the story doesn't end there. Just recently, the plot thickened with tantalizing evidence for a second planet in the system, currently called Gliese 251c. This one is still a candidate, awaiting full confirmation, but the signs are promising. If confirmed, it would also be a super-Earth, but a much more massive one, with an estimated mass around 22 times that of Earth. And here's the really exciting part. Its orbit is much wider, potentially placing it squarely within the star's habitable zone. This is the Goldilocks region, not too hot, not too cold, where conditions could be just right for liquid water to exist on a planet's surface. The prospect of a nearby super-Earth in a habitable zone has made the Gliese 251 system a top-tier target for future study. The prevalence of super-Earths like these is one of the biggest revelations of modern astronomy. Their composition can vary wildly. Some might be dense, rocky worlds, essentially scaled-up versions of Earth or Mars. Others could be water worlds, covered in deep global oceans. And some might be mini-Neptunes, with a rocky core surrounded by a thick, puffy envelope of hydrogen and helium gas. What a super-Earth is made of depends on its history. A theoretical model of a planet like Gliese 251b might have 4 layers: an iron core, a silicate mantle, a shell of water in some form, and an outer gas envelope. The true nature of Gliese 251b, whether it's a big rocky planet or a small gassy one, remains a mystery. To figure that out, we'd need to measure its radius, but that's only possible if the planet transits, or passes in front of its star from our point of view, which we don't yet know if it does. The atmosphere is another huge question mark. For a hot super-Earth like Gliese 251b, some models suggest the atmosphere could be dominated by vaporized rock, creating clouds of silicates. It would be a truly alien sky. However, if a super-Earth is in the habitable zone and has enough water, it could have a water-rich atmosphere with clouds and rain, much like our own planet. This brings us back to the habitability of red dwarf systems. As we mentioned, the challenges are significant: tidal locking and stellar flares. But recent studies suggest these might not be deal-breakers. A thick enough atmosphere on a tidally locked planet could act like a global circulatory system, distributing heat from the hot side to the cold side, potentially creating a ring of twilight zones with stable, temperate climates. And while young red dwarfs are violent, An older, calmer star like Gliese 251 is a much safer host. The incredible longevity of red dwarfs means that if life can get a foothold, it has trillions of years to evolve, an almost unimaginable timescale. All of this makes the Gliese 251 system a perfect target for our most powerful new tool, the James Webb Space Telescope. JWST is an absolute game-changer for exoplanet science. Using a technique called transmission spectroscopy, it can analyze starlight that has passed through a planet's atmosphere. Different molecules in the atmosphere absorb specific wavelengths of light, leaving a unique chemical fingerprint. By studying this fingerprint, JWST can tell us what an exoplanet's atmosphere is made of. It can search for biosignatures, a mix of gases like oxygen, methane, and water vapor that could indicate the presence of life. While we don't know if the planets in the Gliese 251 system transit, the possibility of finding other similar worlds that do makes JWST an indispensable tool. It's already begun delivering incredible data on the atmospheres of other exoplanets, heralding a new era of cosmic exploration. Looking even further ahead, future giant ground-based observatories like the 30-meter telescope could have the power to directly image a planet like the candidate Gliese 251c. This would be revolutionary, allowing us to not only confirm its existence but study its atmosphere in even greater detail, potentially seeing clouds or even mapping oceans and continents. The discovery of Gliese 251b is more than just another pin on the galactic map. It's a story that captures the essence of scientific discovery, the thrill of the hunt, the frustration of false starts, and the ultimate triumph of revealing something new about our universe. It's a powerful reminder that our cosmic neighborhood is filled with more variety and wonder than we ever imagined. As we continue to push the boundaries of our knowledge, systems like Gliese 251 will serve as crucial laboratories for understanding how planets form and whether life could be common. The Super-Earth next door has opened a new chapter in our search for an answer to one of humanity's oldest and most profound questions: are we alone? The answer might be hidden in the faint reddish glow of a nearby star, waiting to be found.